right. Good afternoon, although I think it's more noon than afternoon, and a lot of folks are still having lunch. Anyway, for those that are here, thanks for coming over. We'll talk a little bit about Oracle Cloud Platform and middleware. And to set the context of this talk a little bit, yesterday, Steve Miranda talked about Fusion applications, of course, and the wonderful suite of products that we have. And then Steve Dahib had a session yesterday as well, and he kind of gave an overview of the infrastructure layer that we have with Oracle Cloud Infrastructure, with applications on top. But he made a few interesting points. First of all, hybrid. Hybrid's still important. On-premises applications are there, and they will be there for a long time. And we have to help manage that, and people will continue to use that. There's the part of Oracle Cloud, where people are deploying an Oracle Cloud, and how do we bridge these two things? And he talked about a platform. And so what I'll talk about here today is really two pieces. The first one is a bit of an overview of the platform services that we have and that we are developing. And then the second part is how that also extends to on-premises. Because hybrid's important, as I said earlier, and we want to make sure that people understand that we have solutions that are on both sides. We're not forcing you one way or another. We're here to help you with choice. There's choice and flexibility. And that's what you hear a lot. You heard that about choice in terms of cloud. You hear that about flexibility for using on-premises or cloud as well. So to set the stage for this, we have to start with Fusion applications. When we started out building Fusion applications many years ago, we made a very conscious decision to build Fusion apps on all Oracle technology that we knew we would also make available to customers. So there are no pieces of technology underlying Fusion applications that we don't also make available to the customer. And that was very important to us, because first of all, we learned a lot building these applications, and so we've enhanced the technology stack underneath, like WebLogic and the Oracle Cloud Infrastructure itself, to make sure they have the ability to deploy a complex environment such as Fusion applications, the UI toolkit, and so forth. And so as we have enhanced that, improved it, we wanted to make sure that customers would have access to the same type of technology. And that's very important, because there's, Fusion applications, the way it's been built, you could argue it's a microarchitecture where you have different components. You have HCM, you have ERP, EPM, SCM, sales management, and they all need to talk to each other. There's one data model. Every application stack can talk to another and exposes RESTful APIs or exposes APIs that can be extended from the outside. And that's really what we're talking about here. A large suite like Fusion still needs extensions for other applications. Lots of our customers decide to pick one piece. They start with HCM. They have something from Salesforce or Workday or something else. They have SAP, who knows what. They have third-party applications, bespoke applications, things they wrote themselves, and they need to connect that into an Oracle environment. And so the way they do that is basically by doing integrations, which is what I'll spend the first part of this talk talking about. Workflow between applications is very important. The data sources that flow. One example here would be I have an object in HCM. I have a different type of object in some Salesforce application, and then I need to combine the two to create something new, or I need both types of data to do a different type of application or a different type of transaction. The other piece that's important, and I'm sure you've heard a lot about in the last few days, or yesterday and today, is the new human interface, the new UI. It's no longer just a web interface. It's not just a browser you use, but you really need to have applications now that have chatbot interfaces, digital assistants, voice interaction, so you can talk to the system and it will do operations for you, and then, of course, mobile and web. So we put a lot of effort into making sure that you have a consistent experience across all these different pieces of technology. Document management is very important. A lot of folks today, it's no longer just about a web page with text. You have a document, you have a video that you want to expose, you want to generate an email campaign that has links to content, you want to track that content and so forth. So the ability to extend applications and integrate that with rich content, videos, audio, and so forth is very important. AI, ML is everywhere, so the ability to look at objects and say, hey, you know, I look for a bike. So we go and we analyze all the different images, and when you query a bike, you get all the pictures in your catalog that have a bicycle in it, for example. So what we have done is there's a set of cloud services. There's integration cloud service, which I'll talk about first. Of course, identity management. Everything talks to each other through identity. That's the core of how pieces work together. We have something called Content and Experience Cloud for all this video and audio content and documents. Visual Builder, which I'll spend some time on, and Digital Assistant Service, ODA. So those are the different pieces of technology that we use internally when we build Fusion applications and we extend Fusion applications, but that we also make available for customers to use for independent apps. And the reason we use the word extension, by the way, or extensibility, is that in the older days, in the early days, customers would customize applications. They would customize eBiz Suite, or they would customize SAP. The problem with customization is that the developer, the customer, goes into the app and makes code changes. What happens then is company releases a new patch, applies the patch or the update, and then everything breaks. Because when we build the application, we don't have the code that you wrote. Right? And so all these customizations created a nightmare for support, a nightmare for development, and for the customer in the end to be able to keep up with new releases. And it created a very expensive proposition of doing this. But customizations were important because they had to extend the app for their specific needs. So with Fusion applications, we did that the other way around, and we said, well, we will do extensions. We will create APIs and RESTful APIs and other ways of communicating with our application stack so that a customer that wants to make modifications can extend the application. And by doing that and using public APIs, when upgrades happen from our side, it doesn't break the app. So customers can feel comfortable that if they do an integration with something else, or they create their own screens and they extend whatever it is that they would like to do in HCM or ERP, that when the next update cycle comes, it will just keep working. And that's a big differentiator that we have over others with applications. So one way to do some of this is Integration Cloud. What Integration Cloud does is basically say, hey, here's a service that lets you create and point to different endpoints, create business objects, and then be able to talk, let's say, from Workday to Oracle ERP, from SAP to NetSuite, or Salesforce to NetSuite, and so forth. And so it provides you with a very easy, in most cases, just drag and drop way of connecting multiple different applications with one another. So if you need to take a sales order or something out of one environment and push it into something else, then with Integration Cloud, you can basically just do that with drag and drop. The other thing that Integration Cloud does is, as it says, we have more than 75 pre-built connectors. And so we know a lot about our applications, of course. We also know a lot about third-party applications. And so these connectors already have, where we've already done the work of understanding the data models that these different applications expose. And so if you then want to connect, for instance, Salesforce to NetSuite, you don't have to do the work of understanding what the different objects are that each of these applications exposes. We have already done that work, and so that makes it really easy to say, I want this set of data from this application to send something to that application. And then you can create workflows. You can say, hey, I want an approval process where all these things are automated, but then at some point you need a manual approval from a user in the system. And then the other thing that Integration Cloud lets you do is then create UIs that are integrated in this workflow that create a new set of components to say, hey, this goes to this user, it has a little pop-up, do you approve this transaction, or do you approve this PO, or this exception? It has, of course, the connectivity of SaaS, Fusion applications with on-premises. A lot of our customers using Fusion applications have tons of applications running on-premises, and they need to be connected. And OIC is something that really helps you connect the two different environments with each other. As with everything we do and everything I'm sure you hear in these next 2 days or in these 2 days, is machine learning and artificial intelligence. It's being embedded in every application we build, in every cloud service that we build. One of the interesting things in the context of integration cloud is that it keeps track of all the flows, and it learns about how the system is used. Or it looks at the data, and it starts understanding what the different data models are. And one example of that, it's hard to read on the screen here, but when you need to connect a source and a destination together, and you have a list of fields, you might not know what that field is. So you want to know the username of something. And that username is embedded in one of the source fields or the source attributes. Well, OIC's AI learns what the types of data look like, and it will actually say, oh, this is a social security number field, or this is a name field, or a credit card field. And so when you're connecting something to the other side, it will give you an example of, hey, this is probably what you're looking for. Makes a lot of guesswork go away. You don't have to go and look up every field. It just kind of takes care of that for you. The second piece of information is Oracle Identity. And so as I said earlier, identity, we have two pieces of identity service. One is Identity Cloud Service, which runs in Oracle Cloud. The other one is called IDM, which is a service that runs on premises. Identity is really important to connect all these environments together. It lets you manage the life cycle of users. It lets you set up access management and so forth. It does multi-factor authentication. And as it says there, it does it in an adaptive way as well. So one of the things you can do with IDCS is say, hey, if this user connects from a different IP address or a different area in the world, then pop up a multi-factor authentication screen instead of just letting somebody in. Or in some cases, you might want to have certain applications be maybe on a lesser secure protocol, so somebody can log in, or some application that's high secure, like a PCI-based application, so then you do need multi-factor authentication. Another piece of a cloud service that's important is Content and Experience Cloud Service. We actually use this to build Oracle.com. So when you go to Oracle.com today, that's fully built with Content and Experience Cloud. One of the things it is, it's a centralized hub for content. You can store any type of document in there. You can store videos. You can store audio. It also has authoring and authentication, so you can say, oh, we have the rights to this image, we don't have the rights to that image. We can create a campaign where we know that we can access these fields but not those, so it keeps track of that, so that you don't do something wrong in a marketing campaign, or you don't start sharing data that you're not supposed to share, or you might not have the rights to for that type of environment. The other thing that Content Experience Cloud does, which is really interesting, is you have a lot of video, and then you have a browser, you have a mobile device, you have an iPad, or a tablet, and different types of endpoints. And so Content Experience Cloud helps you take that source data, the source video or the source audio, and it will transform that into whatever the target is. So you don't have to go and create different types of videos yourself. You upload one model in the hub, and it will make sure that it plays it in whatever model that is available. I mentioned AI earlier, so it does image search as an example. I used the bike sample, so if you upload 10,000 images and there's 5 bikes in there, you would actually be able to look for that and would pop up only those 5 with a bicycle in the image. So it makes it really easy when you're looking for content to go and analyze that. Visual Builder. So this is actually a very important tool. Visual Builder is a web-based application development tool. So all you need is a browser and a login, and you can start creating applications. For the most part, it's a low-code application platform. What that really means is you don't technically have to know how to write source code or write JavaScript or something like that. You can just drag and drop fields. You have a library of widgets. You can say, take a chart or take a table. And then in the backend, you just connect those things to business objects. And then you can create a mobile application. You can create a web-based application with the click of a button. When you do a mobile app, you get a QR code. It's a progressive web app, so you don't have to necessarily upload it to the Apple Store for an iPhone. it can create a native application as well. We use Visual Builder for all the new applications in the Fusion application space. And one part of Visual Builder is that we have a web tool, or we have a UI toolkit called Jet, Oracle Jet. And so as we do new work like the Redwood theme, which you've seen here a lot of, all those new widgets and the templates for building web-based applications or mobile applications, we push that into Visual Builder. So as we do new UI development, it will automatically be exposed in Visual Builder. The other thing that Visual Builder does is it basically in the backend can talk to any backend that has REST APIs. So one example that I like to take for this is, let's say you have some resources on Azure, some resources on OCI. Each of these cloud vendors have local consoles, and you want to see all the VMs that are running, or you want to create a dashboard or a console that shows all the different content around your cloud estates. So with VB, you just basically point the backend to an Azure endpoint for VMs, and to OCI, you create a little chart icon, and it'll basically pop that up and say, I have 10 VMs, I have 100 VMs total, 10 VMs in Azure, 90 VMs in OCI. So it lets you, without writing any code, really easily create applications. Digital assistants. So the previous talk talked about digital assistants a little bit as well. One of the interesting differentiators that we have is that we're really focused on the enterprise. So a lot of the skills that we develop and a lot of the understanding of the language processing is focused on business applications. Not about, Alexa, turn lights off, but really about, hey, what is my vacation balance? And, look up this user in the corporate dictionary, directory. We have pre-built some of these things into ERP and SCM and so forth, but a lot of our customers want to use that in their own application as well. And so we have customers that have, like Hermes in the UK is a distribution company. And so they get lots of requests from customers from a support point of view, where they want to know what the tracking status is of something. And typically, they have to file a request on a web page. It takes many minutes or even hours to get a response. So they've taken the Oracle Digital Assistant and integrated into their website so that you can just talk to the digital assistant and say, hey, what's the status of this order number? And it will automatically return that to you. By integrating this, they reduced the number of incidents that they have to manually process by 40%. A lot of happy customers because of that. And it's all the same technology that we use internally as well. So all of the stuff I just talked about needs very little code. You can basically drag and drop stuff. You can extend it if you want to. You can write JavaScript in Visual Builder if you really want to do customizations. But for the most part, it's really high level. Now, of course, a lot of our customers over the many years have written lots of applications with J2EE, application servers running, WebLogic, and write big applications. What's happening now is microservices becoming very popular, and people are writing new applications, and I'll talk a little bit more about that. And also, other than Java, there's languages like Python and R and Ruby and Node.js, so people have their favorite flavor of application. And so this comes back to flexibility and choice. While we obviously have done a lot of work around WebLogic and around Java application servers, we also recognize that a lot of our customers and developers in particular want to write applications using different languages and go to a more cloud-native development model, use Kubernetes and so forth. And so we spend a lot of time in addressing both sides and will continue to do so. There's an evolution of application development, in particular around cloud-native services. Microservice-based applications, what that really means is not so much, microservices can be one of two things. One is you break down a big monolithic application into smaller components. The second part is that you break something down into something really small that starts quickly and goes away quickly. There are two different ways of looking at microservices. Most of the time, though, it's breaking a big app down into smaller components. It provides for much better availability and much easier scalability when something goes wrong as well. Java is obviously still a very popular application language, but Python, Node.js, and so forth are heavily used as well. Or people combine the different languages. So what's happening today is you hear the word DevOps a lot. What that really means is you have the developers that are writing apps and the operational team that actually runs the apps and provisions them, installs them, talks to the customers. Those two teams are sort of starting to merge closer together. So the developers are also responsible for maintaining the service and running the service. Microservices are popular because it really helps with scalability and helps with availability. So when one app goes down or when one piece of a container goes down, the rest keeps running, and it provides a lot of resilience, it provides you with the scalability that you need and so forth. Developing Java apps, so WebLogic has been a product that we've supported for many years, and we obviously will continue to do. One of the things that we've spent a lot of time on the last several years is making sure we can support WebLogic in cloud-native environments. What that means is we added Kubernetes support. We have an operator for Kubernetes for WebLogic. We have the ability for WebLogic to connect to Prometheus, and Prometheus then can be used with Grafana to create dashboards and display the status of your application servers. We've created images in Oracle, in OCI Marketplace, the Oracle Cloud Marketplace, where you push one button and within a few minutes you have WebLogic installed and running, so it's really easy. And we are continuing to making sure we evolve WebLogic, and in the next several months, WebLogic 14.1 goes GA, and that will also support JDK 11. So for folks that want to use Java 11, go to JDK 11, that will be supported. And the reason for this is that there's not everyone is rewriting their applications in a new model. We want to make sure that we can help the existing customer base that wants to stay with WebLogic for a long period of time. Or maybe in some cases, people have a set of existing J2E applications, and then they want to write some different components in a different language and combine the two. Microservices. One project that we have launched, and this is an open source project, is called Helidon. Helidon is a lightweight framework that allows you to create Java applications. You don't have the full environment of a J2E application server. You just write an app in Java. It supports the Eclipse microprofiles, which is an open source project and standard for lightweight containers. And we make that available for people that really just want to write Java applications and create very small containers. All of this needs to support multiple programming languages. So one of the things that you'll hear more about from Antonio later is how we use Kubernetes, or how customers are starting to use Kubernetes as the deployment platform for their applications. And so by creating the container support and the operators for WebLogic, it allows our customers to create a Kubernetes environment, take some of the components from an existing WebLogic deployment, put it in Kubernetes, create new environments in a different language or using a different sort of infrastructure, and put it all into Kubernetes, then support Prometheus and Grafana for creating the monitoring solutions and so forth. All of this needs to be managed. And one of the problems people have is when you have a Kubernetes environment, what typically happens is people download folks from websites, install it manually, but then when you do that, when you download open source projects and install them yourself, you're responsible for upgrades, you're responsible for support, you're responsible for patching. There's no good management framework, and all these things are sort of pushed together individually. And so Project Verrazzano, which is an interesting name, is a project that we are working on where we basically create it's a curated set of open source tools that are very popular in a microservice environment. Prometheus, Elasticsearch, Grafana, and so forth. And so we're creating an environment, a management platform and a management environment for Kubernetes. It allows you to manage WebLogic applications, Helidon applications, or anything else in a Kubernetes cluster. And it allows you to do that in a hybrid environment. So you can have some Kubernetes clusters on premises, other Kubernetes clusters in Oracle Cloud or in third-party cloud environments, and then have one management infrastructure for both. Developers use more languages than Java. So JavaScript is very popular, Python is very popular. And so we want to make sure that we can support the different languages that customers are interested in. Now, one problem with using different languages is that you get different runtime characteristics. Java can have certain performance, Python might have a different type of performance. They run in different environments, they're isolated. And so what we've worked on for a long time is GraalVM. GraalVM is a polyglot environment. What that means is that it's a runtime that can support different languages. So you want to run Python code, you want to run JavaScript, Java, R, and so forth, and one runtime can execute any of these languages. One interesting aspect of GraalVM is also that you can have multiple languages running at the same time. So you can say, I have a Java application, and from within that Java application, I also execute some Python code. So you can actually embed that within Java so that it creates a subshell to execute Python in that same process. One of the interesting features of GraalVM is that it supports something called native image. And native image means it takes, for instance, Java code and it compiles it into a native binary. This is very important because if you want to have an application written in Java that has a really low startup time or reduces memory footprint, and this is the right way to do that. So you have your Java app, you compile it native into an image, and it's just a standard executable from the operating system environment. It increases the performance a lot, and in some cases 10% or more, and it's a very powerful language. Twitter is a reference for GraalVM, and they were at Oracle OpenWorld in San Francisco. And so a lot of the microservices at Twitter are written in Java, and they use GraalVM to execute. And by just taking the exact same language, the same source code, without any modifications, by using GraalVM, they got a 10% performance increase. Now, by doing that, they need fewer servers to run the same workload, so they save money on resource requirements. We also use GraalVM for Helidon, and here's an interesting chart. It shows the startup time of starting up a Java application in Helidon. There's another thing called Quarkus, Spring Boot, and so forth. And so with Helidon, which is really efficient, in 0.9 seconds, that's sort of the startup time for your application. When you take that code and you run it with Graal and do native compilation, you have that little line there, which might be hard to see, but 26 milliseconds. So you have a Java application. It starts up in 0.9 seconds, 1 second, whatever. You use Graal, you do native compilation, you don't change any line of source code, and you execute it, and it goes down to 26 seconds. Right? That's brilliant. Certainly things like functions, which becomes very popular these days, to execute transactions really quickly. Event comes in, it runs some Java code or Python code. You need something that starts up really, really quickly. So with GraalVM and native compilation, you can do that. Another thing that's very important is, so we have Oracle Cloud. We offer a bunch of services. We have the Oracle Cloud infrastructure. On premises, we have an entire cloud native environment that we offer. We have WebLogic, we have the different languages, we have Java, Graal. Everything underneath needs an operating system. And one of the things that we have in common across the two clouds, or hybrid and on-premises and cloud, is Oracle Linux. At OpenWorld in San Francisco, we announced Autonomous Linux, and you hear a lot about Autonomous Database. You heard yesterday and today. And Autonomous Linux is similar. We automatically patch the system for you, we automatically tune it for you, and so forth. And this is important from a developer point of view because a lot of developers are application developers. They don't really want to deal with the operating system. You create a container, you run your app inside. You don't want to deal with patching the operating system, do updates, make sure that things are current. With Autonomous Linux as the operating system underneath your application, you don't have to worry about it. You push a button, you create a new instance, and then when a security vulnerability comes out, we fix it. It just applies it for you. There's no downtime. You don't reboot your system. You don't have to shut down your application. You just don't have to worry about it. So an autonomous operating system is actually quite important, similar to the database. As a database developer, you don't want to deal with the installation of it and the management of it. You just want to run your app and you want to do some SQL code and PL SQL. Same for the operating system. As an app developer, you don't want to have to deal with the operating system or talk to somebody else and asking them to patch stuff. Part of OL is also a cloud-native environment, so all these things I talked about with Kubernetes and so forth, we actually ship as part of the operating system. So if you want to run it on premises, you don't have to go somewhere else. You can just get all of this for us. It's all supported. It's all part of the Oracle Linux subscription and also as part of Oracle Cloud. We have all these languages available. So when I talk about Python and Node, all this stuff is available on Oracle Linux repositories. You just type yum install Python 3.7 and off you go. It's all signed. You don't have to worry about any of these things from a third party. So choice and flexibility is really what all this is about. We want to make sure that people with existing WebLogic applications and existing environments can continue. But we also want to make sure that we support the future of application development with cloud-native environments and so forth. So I talked a lot about Kubernetes and WebLogic. I do want to bring up Antonio. So Antonio is from CERN, High Energy Physics Lab, and it's a very exciting place. And so Antonio uses WebLogic in Kubernetes, and so he's going to talk a little bit about the stuff that we have that he's a big user of and how that's used at CERN. Thanks, buddy. Thank you.
Hello, everyone. So before to start, let me introduce what is CERN. CERN is the European Center for Nuclear Research. What we do is basically studying physics and understand how the fundamental particles interact in the collision in order to understand how the universe started. So, that's me. Of course, we don't do just physics. We also have IT department at CERN that basically supports for physics. We have, in particular, in our group, we run WebLogic and databases. In particular, we have a deployment of WebLogic 12.1.3 on VMs. Basically, we have more than 350 clusters. Our users are mostly Java developers. So we host, basically we offer WebLogic as service for our developers in order to deploy Java critical application in different areas like IT, engineering, administration. Basically, this service is running at CERN since at least 10 years. We did not have any issue. The service was extremely stable, reliable, but and our users were extremely happy. But we were spending a lot of time in maintenance tasks. When a user was asking us a new environment for deploying their application, it was taking us at least half a day, even if we had a lot of scripts that were automatizing the deployment of the WebLogic infrastructure. And so we were mostly focused on this task more than improve our service, make the user experience better. So at some point we started to look around, see how we could improve the deployment, make it faster, easier. And so we started to look at Kubernetes. Why we choose Kubernetes? First, it made our infrastructure, deployment infrastructure, immutable. It means that basically at any time you know what you are running on your services. It was happening with the virtual machine that some of us, even with Puppet, were accessing the machine, changing some configuration, and going away. This was basically this alignment between the configuration. With this situation, it will never happen because basically, when everything is restarted, you have a cleanup of the configuration. Another point, as Wim said before, you can run everywhere. Kubernetes made our deployment portable. We can run this on-premise, on the cloud, on hybrid cloud, multi-cloud, doesn't matter. You just need the Kubernetes cluster. And it made also our system available. Because basically, Kubernetes is self-healing. It was happening that in the weekend, something was going down, and you just need to restart the managed server to bring it up. And this, anyway, was taking manual action. You need to be there to basically automatically, to manually restart the service. With Kubernetes, you can just set up a health check, and it will do for you automatically without human interaction. And last but not least, fast provisioning. As I said, we were able to deploy a new environment in almost half a day. With Kubernetes, I did, I think, a few weeks ago, around 40 environments, new environments in half a day. So, I mean, this is a big improvement in terms of provisioning. Which are the technology that we use? In order to provision in Kubernetes cluster, we use OpenStack plus Terraform template to deploy. For logging, we use Elastic Stack. For metrics, we use the TIG stack with Telegraph, Influx, and Grafana. And for the WebLogic configuration, we use the WebLogic deploying tool. This tool, I really like it because basically it allows us, before we were having the configuration of WebLogic in Docker images. And so if you had any difference between users, you had to have different images for each of them. With this, we were able to have a unique Docker image with binaries, and later to at runtime, when the pod was starting, to inject an YAML file and generate in 50 seconds the domain configuration. Now, what we want to look next, I mean, these are technologies that we already look at them, and we just want to integrate in production. So for example, for the login, we want to replace part of the Elastic Stack with the FluentD. We want to introduce Prometheus and have a look to WebLogic exporter because Prometheus is the most used tool for metrics. We want to have a look to, I mean, actually we had already looked to the WebLogic image tool, and we found it extremely useful because basically, if with just two commands, you can say, I want this version of WebLogic and these patches, and you have a Docker image generated. We were in the past using basically our own packages to install patches. With this tool, it would be much, much easier. And last, the WebLogic operator to deploy. We were not using it. We are not using it yet because basically we have a big requirement that is the 12.1.3 version of WebLogic that is not supported by operator. So next year we are planning to move everything to 12.2 and to have again look to WebLogic operator to deploy WebLogic. So which are the next steps? We want to complete the migration. We already moved most of the development and test environments for our applications. We want to move pre-prod and prod in the next month, profiting of the end of life of WebLogic 12.1.3 in November 2019. But actually, I knew that it was extended for another year. Probably will not tell to our users, just to push a bit more them to migrate to the new version of WebLogic. And also, as I said, this can run everywhere. And so we want to evaluate the OCI as a solution for our disaster recovery plan. To wrap up, what we learned from this? Again, the portability is the key for us, because basically, we are not vendor lock-in. We can run this everywhere, no matter on-premise, any cloud provider. And it made our deployment extremely, extremely fast. As I said, we go down from half a day for one environment to half a day for 40 environments. This is a big achievement. And of course, this increases the productivity because you can focus more on other stuff, on new feature than on maintenance tasks. Of course, this does not come easily because entering Kubernetes is not difficult. Learning the basic concept, how it works, is extremely easy. What is difficult is to get at production point. So making your service running Kubernetes production ready. This is another story because you need to learn how to do it. I say that is a steep learning, so actually is a steep learning curve. But there is also two sides of the medals because basically it's true that when you reach this point of production ready, all the newcomers are able to easily enter in this environment and to deploy new environment by themselves. In the past, with virtual machine, they first need to know about WebLogic and after be able to deploy. and use our scripts to deploy WebLogic. So this was taking much more time in terms of training of newcomers. So that's all from my side. Thank you for your attention.